Hi, and welcome back to the second stream of trying to make a falling sand game in Rust. So, first off, I've made a GitHub repository for the whole code, if anyone's interested. I think I've already put a link for that in the description, if I didn't forget it, but yeah, it should be there. So, for those that weren't there last time or just want a quick recap, and the things we did last time basically came around to, well, not doing a lot at the end, but basically what we have is like a way to like render pixels on the screen just. Since the last stream I've cleaned up the code a tiny bit, so basically I've just split everything up into a few files. So in main we only have like the setup of the GPU and stuff, and then we have a view renderer which contains the I should probably start with this. We have what I've called the world view, which contains the array I've talked about, which contains like the pixels that should be displayed, and then there's the view renderer which actually takes that array and or texture it is right now and renders that to the screen using the shader we wrote. So I want to get a few things done today. First off, I've kind of noticed that we've been doing a lot of extra work in this view part, because we make a buffer and then we copy that buffer to a texture and then we use that texture to display anything. But I've noticed we can just like use the buffer directly and index that in the shader, so I quickly want to change that. And then the other thing is that I actually want to get started on the whole compute shader ordeal, so I wanted to like write a simple compute shader that changes something in this buffer, and then and then that gets displayed. So yeah, I think we'll just get into it. So for removing the whole texture thing, I think that should be not that much work. So basically, let me see, we can more or less remove well, first of the whole texture setup here. So this. And then this isn't temporary buffer anymore, so I just remove that. We'll rename that for now. And then obviously we don't need to copy anything over, so this whole part can go too. And the sampler and stuff can also go. So I've also noticed that textures generally apparently don't perform as well if you just want to index them as just like using a raw buffer. And the only real benefit of textures is that you can do like this whole sampler thing where you do like have like a filtered access to the texture, but we also don't really need that, so that's like another benefit, that it should run even faster. Um, so let me just quickly see if I still have like some temp buffer stuff in here, but I don't think so. Yeah, so we don't need the... Hang on, this is the sampler, so we don't need the sampler anymore. And instead we only have an entry for the buffer. Then I think just do texture sample... No, not... Oh wait. The binding type should be a buffer. Oh, I hate that it does that. And then the type is buffer binding type. So what do we have available here? Yeah, I guess we want this storage thing. I'm not actually sure what the difference is, to be quite honest. But storage sounds so plausible. And let's see, in this... Well, we right now we only read it, but later on we also want to write to it, so I leave that false. Then has dynamic offset, I don't think we need that. That's, I think, only if you do like some dynamically sized things. And min binding size, it's an option, so I'll just leave it at none for now. We need it later, I'll probably notice. Missing feed cover, okay. So this binding can now be number 1, and I should change that in the shader. Oh, actually I change that in shader later. So these should also be dated. So this isn't a texture view anymore, but also just a buffer. And which is that buffer? Why is it complaining now? Oh, just because I didn't save, okay. So we don't need to save these anymore, and I'll just save the whole buffer here for now. Okay, so for the shader, actually let me check how they did that in this example here. Was it? It was here, yeah. I put that to the side. So yeah, we want to basically do this in the shader now. Oops. So this is now binding 1, and this binding doesn't exist anymore. And then this is, I guess I'll call it the world view to be like a bit more consistent. And that's storage. And here we only read from it. And that's an array with recurse. So one thing that also means is that since this buffer now only, like, we interpreted it differently now. So before we had like this texture which had RGB values, but I think now we more want to interpret it so that the value in the buffer represents like the type of element that should be in that position. So, oh, actually, let me quickly change this to buffer size as well. So I think we don't need this ×4 anymore. And I also move that here. So now, for now we only have a single byte per pixel. Okay, now in here, I've also kind of changed the names of things a bit, so the thing that contains the screen resolution is now the render view uniform in case we need to add something else. And yeah, some other names are changed, but the code still does exactly the same. So we probably want some kind of function to, because this buffer is now one-dimensional, so we probably want something to translate that again from a 2D coordinate into a 1D coordinate. And that actually means that we need to tell the shader the size of this somehow. So I think we will also need a view size in here that we then set to the same as this buffer size. So in here, yeah, exactly that. And then in here we also have this view size. Did I change it the same? Yeah. So this function here, which I just call like port to index maybe, takes like a coordinate and returns the corresponding index into this worldview array. So I think what it suggested here is actually more or less exactly what we want, just that the y coordinate should be multiplied with the view size. Yeah. So now we don't sample a texture anymore, but instead we return. So this is a bit of a question. I think for now I'll just return like one color for an element of type 0 and another for type 1. And I think eventually what we want to do is also like push some sort of list into this shader where it like maps an element type to a specific color to be rendered. But I think for now I'll just do like this. No, that doesn't. It's probably something like this. So basically, we take the UV coordinate that is passed in, then we calculate the corresponding index into this worldview array, and in that array, oh actually, this should then also probably be U8 and not vec4. I don't know why I did that. So it's just an array of U8. And then, yeah, then this makes sense. So I'll split this up a bit. Yeah. So let's create like an index thing, which this is actually, yeah, I think that makes sense. So the UV chord goes from 0 to 1. So, for example, if we have a UV chord of, I don't know, x1 and y0, then we first multiply that by the view size, which would be like the size of the final like rendered thing. So let's say the grid has like a resolution of 512 by 512, so that would result in 0, 512. And then we pass that into this function, which gives us the index. So then we take that index to get like the how do I call it, like the element type, which is just getting that out of the world view. And then for now, let's just act as if this is like a F32 and use it. I probably missed some type converters in this, we'll see. Yeah. Oh yeah, and we need to update the buffer usage here. So we definitely don't need map right in here. And copy source also not for now, so I think the only we really need is, yeah, the storage one. Yeah, unknown tile. So how is there actually like a thing as unsigned types in WGSL? My eyes. Or maybe you don't have like a... Maybe you can only go use 32-bit types? Yeah, looks like it. So that changes a tiny bit what we want to do here. So that means that this vector should already be U32. Why is it complaining now? Oh, so that's probably where we need like bytes mark, something like this. Yeah, and then in here we also just do a U32. Oh, because we have read here, I think we can't only have storage, so you probably also need this. No, that doesn't really make sense. I mean, yeah, I think that doesn't really fix the issue. I can try. No. Maybe I actually have to true here so that it matches. with the, because we only do read here. Oh yeah, okay. That definitely doesn't look right. So let's again do the whole. So if we have this index and do, let's figure out which coordinates it's actually giving out if we are indexing into the right parts. So if we take this index and multiply it again by the screen resolution. So this is screen resolution.x. Oh wait, no, that doesn't actually make that much sense. Oh well, we can. That index should go between 0 and whatever the size of this array is. So let's maybe try to figure out how big this array is. I think there was some place where we actually need this in any case. I think, well, anyway, I can just do. Yeah, this. So let's see. So we have 16,000 elements. So this value, the index we get here should like start at 0 and on the top left of the image and go to 1,600, 16,000, whatever, to the end at the bottom. So if we do, if we take this index and divide it by 16,000 like this, then we should like be able to see if we're even calculating the right one. Actually, let me quickly put in every part so it's easier to see. But I think that looks more or less correct. Yeah, I'd say so. So we start at 0 and slowly go up. So I wonder why this doesn't work. This looks like we are having like some sort of issue with the offsets again. Because it looks... It looks more or less correct. But we are like off by a few pixels every time. I wonder why that would be. So I can kind of do a bit of testing if I... where was that here? Oh, actually that... Yeah, so if I limit the Y again to also be like in some sort of region, it should be... We should be able to see that it like is roughly in that region, but just that the offsets are like... It's like shifted a bit around. By doing that. Doesn't actually change anything. I was just making sure that... Yeah, no. I wonder if it's maybe just some sort of rounding issue, because we are like, obviously these are still floats when we pass them in, and then we multiply them and cast them to a U32. So maybe if we also already require these to be U32, and then when doing this here, actually, why would these be float 32s? These should probably also be U32s, just to be sure. Because I really want to make sure that we don't get like any floating point inconsistencies. Are these already the right format? Yeah. Let's get in there. So I say that this should be also U32. So now we're doing only integer ma. And now everything is broken. That's not a good sign. We quickly change these back just to check something else. Which is if I... Yeah, no, it's comparing it. Maybe if these I put them to be integers, when as soon as I put them in the method, that changes something. Alright. So if I make this a U32 only. Right now it's an issue here. I just stay with the F32 approach for now. Maybe the issue is something else. Can't work with 3 and 7. Oh, yeah, okay, so these are 2 again as well. Yeah, so we still have that issue. Why am I struggling here? What happens if we lower the resolution of the window a bit? I wonder. Maybe that will make it easier to see. Wait, not the resolution of the window, more the like resolution of the pixels. So like this maybe. The one thing I'm noticing is that this is very confusing. So, I'll just try around a bit to make sure that it's first this buffer is actually mapped in the way that we expect. So if I like make it start at like the top, is it still that's still the top in the final image? Yeah, okay. And if I do something only at the bottom, what happens then? So it actually stops before the end, which would make sense, since it's like having fewer gaps than we would expect. But still don't see why it even would be in the first place. Like this feels just like a off by 1 error or something. Maybe I'll try doing like a -1 here again. Now it's even short. Okay, but when if at all, it should be a +1. So the arrow is U32 here, and the arrow is U32 here. Maybe this method is not doing what I expected to. Yeah, this seems like what we would want to do. Maybe let's try to figure out how many of we actually are. So I'll do like I'll add something here and let's like start with 10. Well, actually, I wonder if I just fill a single row with pixels. So let's just do y equals 50. Yeah. So this already looks nothing like I would be expecting. Because why would there be like these steps in between? Yeah, sure, let's also do... No, not and. Let's do like a vertical and a horizontal line. Oh. Okay, and what does the thing happens if you only do like a single pixel? It's so weird. But I guess if we really had an issue with the indexing, then it would probably be in this function. Let's maybe try skipping this multiplication step, so I'll quickly make another function which does like uv to index. Well, I wanted to skip this function explicitly. So what this would do is for... So uv goes from 0 to 1 in each part. And then we do uv... Actually, I really don't see why this wouldn't work. Let me try some debugging with the with showing the index again. Oops. Oh yeah, obviously that was divided by... Huh? Oh, because we need to first do this. So that the division is actually in floats. Is there like some sort of render debugging tool? Like something like render doc just for Linux? Or does render doc exist for Linux? Oh yeah, it does. Okay, no, let me quickly solve this. So let's try to find something out with that, maybe. So because I'm wondering if, like, I can't really discern if there's anything changing in this value in here, and the only really way to see this is to have like some sort of color picker or something. So just showing sand, Farbe, this. Maybe not. Why does it instantly quit? If I... Yeah, that runs. So why wouldn't this run? Okay. I wonder if it's again like some sort of issue with... I don't know. That's really annoying. Well, I could just divide this, like multiply this by 0.5 again to just see, scale it down and see if it's actually happening, because maybe it's just my eyes being too blind to see anything. Like I can't really see any change in the lower region, and I'm not sure if that's me just not seeing it, or if there actually isn't any. Actually, let's do like, I don't know, this, and then this. So that should probably only display something. Wait, couldn't you do this in WGSL? Well, I just do then this and then it. Actually, let's just make color this. Color, okay. 32, yeah. So up until there it definitely looks right, so maybe it's to 0.9. Yeah, that looks good. But actually, now that I see this, there's still like this, like there's these steps, which definitely shouldn't be there now. So I think the index function is just plain wrong for some reason. So at least I think we kind of know where the issue is now. Well, and yeah, that has to be somewhere in here. So maybe it's a floating point inaccuracy thing after all? Let's try calculating the coordinate first. So maybe coordinate coordinate is as we take the vec2 of u32 and then we take the coordinate divided by the render view uniform dot screen resolution and then times the view size, and then we put that in here. Oh, and then it's just the XOR part. And actually, let me also put the element type in here, because if we accidentally fix it, then otherwise we won't notice it. This is also 22. Oops. Well, this looks more like what we would expect, actually. Because it like starts at some point and then everything after that is filled. And actually that also looks like it's just running single pixel, so maybe let's actually fix it. Let's do like a square here again. Yeah, like this. Yeah, okay, that definitely fixed it, but I don't know why it would have now. Unless it really was some floating point inaccuracies just. Oops, I moved the wrong one. Yeah, okay. So that works now. I actually now we can like step by step change these back to figure out what exactly the issue was. So okay, that still works. So what if we make this in F32 already? Maybe I just had some issue in the mar. No, okay, so that's the problem. So that means that we definitely can make this U size U32. I think. And get it out here. Because I like want to save on the cast, so it's U32 here already. Nope. Somehow putting U32s in here just breaks everything. Well, let's just leave it for now. It works, I guess. Let's save it. No? Wait. Oh yeah, I should probably put these back. Yeah, okay. So now we can use this buffer directly to draw, which is nice. So now let's actually get into running some compute shaders to write stuff into this buffer instead of doing it directly here. So I guess I'll make like another file here. So in the end, the compute shader that writes something in this buffer will be the one that like well, let me quickly explain it again for the ones that weren't in the first stream. So the end idea is that we have two compute shader passes, and the first one like calculates all the possible movements that pixels could have. So if you have like let me draw this again quickly, it wasn't much work. So you have the screen, and then compute shaders run in like multiple threads, I guess you could call it. So each thread will be responsible for a screen region. But there will be issues if we have a pixel in this region that moves over to this, and simultaneously in this region there's a pixel that also moves to the same place, because one of these threads will write to the same place before the other, and we don't really know which one. So we need to resolve that somehow. So we do two passes. In the first one, we go over the current state and record all the changes that pixels want to make. So in this case, we would have like we record one movement from the pixel in this chunk that wants to go to here, and one from here. And then in the second pass, we take that list again and we check for conflicts and like choose which one of these actually gets to move. So if we now do a shader that writes to the final rendered buffer, that would be the compute shader in the second stage, I guess. So let's already pick a name according to that. Let's maybe do it like resolve conflicts or something. Resolve pass maybe. So this will be resolve pass, and this will, I think, actually let me pull up the compute shader example here. So I think there was like a specific render pipeline. Yeah, here there's like these compute pipelines, which are specifically for compute shaders. So we'll probably have a compute. Oh, I should probably include this here to actually get highlighting. It isn't giving me anything here. Oh, because I just was stupid. We should probably also declare the struct first. Resolve pass. Click. Then we do yeah, pipeline, which is a compute pass, maybe. Well, it's not the pass. It's a compute pipeline. Oh yeah, I was just blind. Okay. And then this will also take, just like here, probably a device. And oh, actually we don't need the queue anymore because we don't write anything. We don't copy the buffer over into the texture, so this will take a device. And oh no, let me turn off Copilot because it's getting annoying again. Device. And it returns set. So at the end we get self with pipeline. And then the pipeline will be no device dot create compute pipeline, and that takes a compute pipeline descriptor, label. Yeah, actually, just let's label this. Why not? So this is the resolve pipeline. Or maybe resolve isn't good. Or maybe it's we should name it more like move pipeline, because this is the one that moves the pixel and the other one that creates candidates. So let me rename this. I think that makes more sense. Okay, so label, then layout. Oh, we also need that. So what type was it? Compute pipeline descriptor. Yeah. No wait, that doesn't make sense, huh? What should? Oh, that's just a pipeline name. Okay, okay. So what does that look again? Okay, yeah, let's just put it in there directly. But I forgot completely what these actually do. Did we have to do something similar here? Oh, actually, I think the pass itself I left in the main file. No, did I? No. No, never mind. So in the... Okay, maybe this... Oops. So in this case it's pipeline layout descriptor. In this case it's just a pipeline layout. So what do we actually need for a pipeline layout then? Oh, okay, you can just do none, obviously, of course. I should look at the example more. Then here. Module will be the shader, so we need the shader. So this should work similar to in here where we load the shader. I think we can basically do the exact same. So this will be, I guess, just move for now. So this was called module. And then finally, entry point is the name of the function in the shader that will be called, and yeah, let's just call it main. That's fine. Okay. And then we need a function to like actually execute this. So let's see how they do that here. Oh, and we probably also need a bind group again, but I think we should be able to reuse the bind group from over here. Because this world view already provides like a bind group. And that bind group is like the thing that contains the buffer and the layer, the render view uniform thing. So I think we can just reuse that. So yeah, let's get to the execute part. Let's see, what did I return here in the render? Nothing. Okay, then let's just return nothing in here for now. So this is where we do. Wait, what were the parameters? No, over here. So yeah, we probably already also want to pass in some sort of view to get to the bind group of it. Obviously, yeah, okay, that makes sense. And then device and queue also are probably needed. So let's take these for now. So we have this, and then device and queue. Okay, so we do where do they do the rendering? Over here. So that the encoder, we probably did we do that in here as well? I'm just cross-checking to make sure that these functions are somewhat similar, but yeah. So we again create an encoder. Actually, now that I see this, I'm wondering if it makes more sense to create the encoder somewhere in main and pass it in both. I'm not sure what. Let me quickly check what like the definition of an encoder is. Encodes a series, can record and finish to a chain which may be submitted for execution. So it would probably make a lot more sense to like not make multiple encoders and instead put all of these in one encoder, I think. Yeah, because otherwise the resources would probably need to be reallocated or something like that. So let's take this encoder part out of here and instead pass it in. Command encoder. And let's instead create it in main. And I think we don't need to pass in the queue anymore, because the only thing we really did here was queue.submit. So let me take this out as well and just pass in the encoder. Yeah, okay. And then this is going to... This can be removed. Okay. So now let's do the exact same here. But excluding the target, because we're not rendering to anything. And we need to include the review here, so... Okay, so now let's instead directly, so we'll start with the pass directly. So that was begin compute pass, so like this. Oh, actually, before I do that, let me quickly check if everything still works correctly. Nope. Oh no, it's just complaining because the shader doesn't exist yet. And something else? Or did I mess something up here? In... Oh, because we don't need the queue anymore. I don't know why that took me so long to understand. Oh yeah, and we need to include the power thing again, so that's use standard move, I think? No? A borrow. Oh. That makes sense. Okay, and apparently doing the rendering needs a mutable reference. That's fine. I think we also need to make them include... No, wait, it's... Oh yeah, okay, right. Whatever strokes, like this. Yeah, okay, nice. So... Okay. I think it's saying that we also don't really need the device here anymore. But I think we might need that later, so let's just ignore that warning for now. So, okay, now. Begin compute pass, and that takes in... Oops, I misclicked again. Of course, the compute pass descriptor. It's always the descriptors. So, label none, and timestamp writes. None. Okay. I wonder what that's used for if you use that. What's additional? Oh yeah, that gives you a compute pass? Yeah, that makes sense. And this has... Oops, this has to be mutable again. Okay. So now we have a compute pass. let's see how we actually do something with that. So yeah, it's pretty similar to a normal pass, I'll just call it. So we first set a pipeline, which is self the pipeline, and then we set the bind group, which is wait, sakanaa. Oh, okay. So we do pass.set bind group, which is bind group 0. And then we again use the one from the view, so it's view.bind group, I think. No? Oh, it's just a field. Can I really do the same here? Yeah, okay. Oops. I should really switch to some different editor sometime. And offsets are just empty again, I think. I think that's what we did here as well, yeah. Debug marker, okay. Okay, so now comes the interesting part. So we need to dispatch some work groups, and what that basically means is that you that's basically how many calls you make to the compute shader, and these can have multiple dimensions. And so the idea I had is, so within each work group there's again like this split into different sizes. I think there was some graphic I saw. Yeah, it was this one. So basically each work group has like a specific size, and I think that size is basically like the number of threads that the GPU will use. And then you can dispatch multiple of these work groups again with a size. So this is the part that we're doing right now. So I think for this amount we should already think about how big each work group itself is, and I think the best idea is if well, first off, apparently you should make work groups sizes themselves to always be bigger than 64, because most GPUs have like 64 threads or more. But obviously if you're doing less than that, then so the GPU always runs all the threads, even if you're not using all of them. So you're basically throwing away compute power if you're not using all threads at once. So I think for the Z size of a singular work group, we'll just leave it at 1. And for the X and Y, we'll do 8. So 8 times 8 is 64. And that means basically that each work group itself will like process like an 8x8 area of the view buffer. So that means that the amount of work groups that we are detaching should be that size multiplied by the, or not multiplied, should be so that we have enough to fill, yeah, like the whole buffer with 8x8 tiny squares, I guess. So I think for that we need to look at the size of the view and divide it by 8 first. So let's call this something like work. Well, that's actually the final amount already, right? When we divide by 8, yeah. So how do they call this? Number of work groups. Work group dimension, which is do we actually have some property on the view to see how big it is? I think not. Here's the view. Well, I think technically we have the uniform, but that's not really the best, so let's actually just add a property which is like size, which will just be this. Wasn't there actually like a tuple type in Rust? That might be a bit cleaner. Yes, so how do we denote that? Just like this. Yeah, okay, nice. So then was the part where we calculate the size? So now we can also remove this physical size thing, which doesn't really make sense. So let's call this just size. Like this. And then for all of these we'll do the buffer size dot width. It's now size 0. And the size of 1. And then down here we also pass in the size. So here we can do view.size, but we divide it by we basically just divide each dimension by 8. But in that we have to definitely round up, so integer division doesn't round up, I think. So let's see if there's some way to do that in Rust. Okay, there's diffs here, so we want to do view.size 0. And then we do view32 diffs here. Oops. So we divide the view size width by 8. And then we do the same for the height. So and then this is workgroup dimension dot 0 and workgroup dimension dot 1. And z is just 1. Okay. So that's the dispatching. So is there anything else in here? No. Okay. So yeah, let's take a look at the shader now. So let's see how that looks here. So okay, so first of all we do need the same as here, where we like get access to the the uniform and the buffer. Okay. And then you need to mark it as compute, so let compute, and then also you need to add the size of specific work group, so that's work group size, and in our case we want them to be 8 by 8 each. And then we need to figure out both the global invocation ID and which is basically in which invocation of these we are. But we also need to figure out the local, and I don't know how you get to that. So maybe that's explained a bit better here. Okay, yeah, so there's also local invocation ID. Actually, what's workgroup ID then? Is that like just a like unique ID? ID? Let's see here. compute failures in work groups. That doesn't really help me. Where do they mention this? Oh my god, I'm so confused. I'm confusing myself with tabbing around the whole time. So let's try to search for work group ID. Ah, there we go. Current invocation, the position of the work group in the overall grid. All invocations in the work group have the same work group ID. So that's what's global invocation ID then? Oh, okay, so that's an ID. And this is like the coordinate, I guess. So is there something like a coordinate for the local position? No, that's for completely different. So I guess you would have to compute that for yourself, maybe? Kubernetes server. Yeah, okay, so I guess we need to compute that for ourselves also. So let's do function main, which takes in this where was it? This workgroup ID. And also the local invocation. Oh wait, actually that's probably already what we need, right? Wait, but this is also reg 3. So I really don't understand what's the difference between workgroup ID and global invocation ID. Well, let's just use these two for now and see later. Because that's also the one they use in here. Yeah, okay. So that's global invocation. No, I really don't understand the difference between the global and the local one. Because now it seems like the position of the... Oh, maybe this is... No, that also doesn't make sense. This is really confusing me. So local ID is its position in the workgroup grid. And global is its... Ah, okay, I understand. So we actually want the workgroup ID and the local invocation ID. So what the global ID is basically, it combines the local and the workgroup into an ID that is unique for over all invocations, or like, yeah, over all invocations, yeah. And so we want the local one, which gives us the position within, like, within these, and the workgroup ID, which gives us the position inside this this 8x8 grid of these work groups. Okay, so we want the local invocation ID. Which is local ID, which is a vec3 of u32. Okay, that makes sense. And then we want the workgroup ID, I think it was called. Yeah. I hope I understand that correctly. But actually in the global... Okay, so I think I mixed them up. So local should be within this one, and then the workgroup ID is workgroup ID, also vec3 of u32. So let me swap them around, so that's a bit easier to visualize, I think. So to figure out where the heck which part of this array we want to be modifying, well, actually, first off, I can like kind of just use this function again. And now that I think about what we actually want to do, I'm noticing that the global ID is probably basically what would allow us to instantly get to coordinate. Because what I would have done now is use the workgroup ID and the local ID together to calculate this coordinate, but I think the global invocation ID is basically already the same calculation, so actually let's just use the global one. So let's do global ID, and then we don't even need the second one anymore. So one thing we first need to check is if the global if the global invocation ID dot x is greater than usize, or if the y value is greater, then we are basically outside of the bounds of the array. Then we can just do nothing. And in any other case, we get the index from the global invocation ID dot xy, and the z part will always be 1 because we chose 1 both here, and I think if you don't specify anything for the z here, then it's also 1 automatically. So for now, what I think might be interesting to visualize is to just use something like the local index, maybe. Oh, wasn't there like a index? Index is probably pretty nice. To just like set some value in the buffer. So let's temporarily also get this local invocation index here. And let's just call it index, it doesn't really matter. Let's just single u32 right here. So let's just do world view at the index is equal to, and oh wait, that's an issue. Local index at the index is equal to the local index, and then in the rendering part, what I would like to do is in the shader, is not just use the type, but use the type divided by 64, because in theory this local index should only go from 0 to 8 times 8, so 64. So if we divide that again... Jesus, I'm so confused again. If we divide it by 64 again, then we should get the value from 0 to 1. So we should be able to see sort of this like grid. And then finally we actually need to run this whole thing. So let's do... But first off we need to create this up here. So let's do like a move pass. Yeah, just take it twice. And then in here we do move pass dot execute, which takes the... Oh, actually... Yeah, okay. Which takes the view, the world view, and the device and the encoder. Yeah. So hopefully that should work. No definition is scope for global... Oh yeah, I just called it global ID. View size. Oh yeah, that's render view uniform dot view size. Greater than can't work with... Oh yeah, okay, because this is a float. Okay, then let's make this also float 32. Writing, okay, so we don't need to read at all, we only need to write. I wonder if that works. Doesn't support write only index. Yeah, okay, then that doesn't matter. It's just to read and write. Is there like a combination of read and write? That should be in the types again. Maybe let's check for the storage. Oh yeah, read underscore write. Okay. In the compute byte pipeline, incompatible byte group at index 0 should be compatible with an implicit bind group layout without label. What is the difference between an explicit bind group and an implicit bind group, I wonder? Implicit bind group. Thank you for that search. And actually, it's also saying entry expected shader stages. Oh, yeah, okay. So in the shader stages also need to be computed each time. For both. They can only be compute. Then we probably need to create a separate bind group for this, I'd imagine. Yeah. So, let's do like make fragment like render bind group, which takes in the device and just returns actually bind group layout. Yeah, which just returns this whole thing. And then we also make compute bind group layout. It also takes in the device. And then the small is the same, but we do compute here. And then we don't actually save the bind group layout anymore. Oh wait, so we still need to save it. Because we also need to do this is getting kind of annoying. I don't really want to add 1000 properties to this, but I guess for testing let's just do it for now. So we have the render bind group layout and the render bind group, and then we also have the compute counterparts. But I think at some point we should like be a bit smarter about saving these layouts somewhere and stuff. And I think I delete the function that they need here. What was that function before? Yeah, this one. So this is going to be the render bind group layout, which is going to be that should be correct. Oh, right. Why isn't it suggesting it? Why just see? Oh, because save doesn't exist yet. Okay. Then let's not make these save, but instead just call them on the struct directly. So that's save like this. No? Oh, yeah, okay. So we have to do word. Okay. So we make a render bind group layout and we make a compute. One. And then we make a render bind group, which takes the render bind group layout. Actually, let's make a function for that as well. So we make which takes in oh, and we should probably return these. So that returns bind group layout as well. No, not a layout. Bind group. And then we do basically this whole part here. Just with the given layout. Oh, and it's going to need both the which is which is also a buffer, I think. Yeah. Oh, and device. So down here we do make bind group, which for the first one takes not the render view uniform, but the render view uniform buffer. And then the layout is going to be one for this, and one with compute again. Oops. So this is going to take the... Which order did I have these? Okay, first the render. Render bind group layout, then the render bind group, then the compute bind group layout, and then the compute bind group. Oh, I mixed them up, of course. So like this. Okay. And why are there some errors up here? Oh, okay, because we don't actually return these, so now. Okay. So in here we do view dot This is going to be the render bind group. And then in here we are going to use the compute bind group. And main. Oh, this is going to be get render bind group layout. Oh, and actually in the no. So now the issue is only the implicit thing, which I don't really understand. This error. Maybe let's see what that gives us. Or does implicit mean that we don't actually need to? Let's look at the example again. So the issue is with the bind. So how do they do this over here? So they set the bind group to this. Oh, so they more or less just let the so that like there's a function to automatically calculate this layout. That's interesting. So let's here redo this. That's a bit tricky actually. So that means that we at least don't have to make this view thing that cluttered. So let's remove the compute bind group part from here. And instead make this actually a function that just takes self after all. So this part we can take and use directly in the render bind group. Yeah, that's the render bind group layout. Okay, and then this function make bind group is still going to take a layout and is probably still going to do more or less the same as this. I should have just left it in there actually. So this is going to be the layout. And this is going to be self buffer and self what render medium from buffer. Okay, so now from this move pass we can take the but I don't really want to create layouts every time in here. So I think what we need to do, which I don't really like, but yeah, let's just do it, is take also the world view in here, which basically makes this whole thing a bit dependent on the world view you pass in new, which is why I'm that happy with it, but let's use it for now. And then we are going to save the view layout in here. View layout. And it's going to be view dot make bind group, and the layout is then going to be where we do pipeline dot get bind group layout. Like this. That's hopefully going to fix it. Wait, that gives you a bind group? Oh, they only need to get the layout here? Huh? Okay, well then we can't even take the view in here and have to do view bind group. So that basically means that this whole move pass is then tied to the view you pass in at the beginning. So this is going to be this, and this is also going to be a bind group. And then here we're just going to do self.view bind group. Oh, but then also it's tied. It still needs the view size. Then let's... Well, I think the best course of action over the long run would be to like do some sort of like use some kind of Rust smart pointer to just point to the view. But for now, let's just save the view size in here. Was it the view 32, I think? Then view size is going to be view size. Because this is going to have issues as soon as we start resizing the views. But yeah, let's just use it like this for now. Okay. Yeah, okay, so that actually worked the first try. So, you can see that like we have these 8x8 areas, and each of those is computed by like one of these. Where do we have it? One of these work groups, and then each of these 8x8 areas calculated at once in this in the shader, where like these 64 threads are like dispatched at the same time. This is a shader. So yeah, that works great actually. So I'm kind of not happy with the if we have here, because branching in shaders is always not a very good idea. So I wonder if there's some way. Well, not really. Let's just leave it for now. So I also kind of want to do like visualize the workgroups themselves a bit better. So actually, what happens if we use the we can use the global ID. Global. Is there something like the local index but global? Here. Doesn't seem like it. Just it's probably something else entirely. Yeah. So that's probably why they calculate that in here for themselves. Yeah, well, I'm not too concerned with trying that out for right now. So, well, actually, it might be interesting. No, let's just leave it. The only thing that would do is like, I kind of wanted to give each of these also a unique ID, which would like allow us to use a different color for each of these like tiny squares too. But I think that's not worth the effort, because we would have to change stuff here and over in the other shader as well. So let's just leave that. So yeah, but this basically means that we also got the. Did I break something now? Oh yeah, I removed this. That we also got the compute shader running, which is really nice. So maybe let's actually clean this up a tiny bit with the whole like having the view at the beginning here, but because I really don't like that. Well, I don't really mind that the view is passed in at the beginning, but what I don't really like is that we save the size separately from the view. So maybe instead let's save the view in here as a oops. So where was RC again? Okay, in RC. Nice. So let's use the RC to the view instead. And then we can just access it whenever we want. So an RC is basically like a pointer for those that don't know. So it's a pointer to the view, but it's a reference counting pointer, which why it's called RC, which basically means that as soon as nothing is referencing it, the world view will get automatically destroyed. So it takes care of that. So we'll take an RC to world view in here and just use it directly. And then in here we're going to do self.view. Oh wait, we still need the view bind group. Yeah. But that means that if the size of the view changes, that's not really an issue anymore. That's dot size dot 0. So that's really nice. And then in here we should do some sort of thing where well, maybe we don't really need a mutable reference to the view anywhere. So let's maybe just do this for now. Yeah. So let's just make a RC here. But I don't think that's really would create any progress anywhere. Oh, okay. Maybe 12. Richard doesn't. But the issue is because this takes in. View by career. Okay, so let's make this also just take in RC. So view of the world view. It's going to read view dot. Okay, so now we need to clone it in each of these instances to get a new RC. Yeah. And probably something is like that. Where's the last ever here? Oh, for the reside it does have to be mutable, right? Which I haven't actually implemented yet, but once that is a thing. Okay, so then in that case, let's also make this. Oh, well, I'm still. That's annoying. I really don't like that we need to pass this in at the start. Yeah, I'll just not do the RC thing then after all, and instead do this, which I really didn't want to do, where we pass in the view both up and up there, also up in this new and down in the execute. I'm not really happy with this because this means that if for some reason we pass in something differently from here and there, and especially something with different sizes, then that's going to be not great. Well, it is what it is. Maybe later we have to do something different. We'll see. So this doesn't need an RC anymore, but just a reference. And also don't need this. Did I miss something? Oh yeah, okay, so we need to pass this in again down in main. Oh, this I was just being blind. Reference to the worldview, and then beginning. Yeah, this is also a reference. No, yeah, this should be a reference, but obviously I need to move the whole RC part here again. So you can go as right. And then I'll actually like it a bit more if oh, well, it does pretty matter. It should work either. Okay, so that works again. But quickly wanted to take a look what's the warning actually it's giving us. So new size in render isn't being used because we in resize because we don't resize anything yet. And then we don't need the device in here too, so I'm still not sure if we are going to need it later, but I'll just remove it for now, and I'll do the same for... Oh, I can remove the debug here. I'll do the same for this view render as well. And what's the warnings here? The render view uniform. Yeah, I guess that makes sense that that's never actually accessed again, but it will be accessed again once we do the resize, because then we'll have to update this uniform. So that is fine. And the other one is in here, so I think these are the only two warnings. Yeah. Okay. So that still works. I wonder what happens if we resize it actually. Weird stuff happens. But it's whatever. For the resize, what we have to do is basically just resize the buffer to fit like the whole scene again. So let's like try to do some stuff with different pixel sizes maybe. That works, and maybe select some like random number that isn't the power of 2. Yeah, that still seems to work. Well, mostly. I wonder if we're still doing one too many here. So maybe this should be greater or equal. Because you can imagine if we go over the X, then it wraps around to the next column. Yeah, so that was the issue. Okay. Nice. So that's more or less everything I wanted to do for today. I think I will do... I'm not sure if I will do the resizing on the next stream or just off stream. But I might just do it off stream because it's honestly not that much. It's just really just resizing the buffer and nothing else. But yeah, so I think that's everything for this stream. Thank you for watching. I hope this was a bit more interesting than the last stream, because we actually made something, like I felt like we made a lot more progress in less time. But yeah, that's always something that you can't really know beforehand. So yeah, thank you for watching, and I might see you next time. Goodbye.